Math 7 1.1. We're going to be talking about representing rational numbers on the number line. To begin this lesson, we're going to find the absolute values of positive fractions. But first we need to establish a couple of vocabulary words. An integer is a whole number. For example, 0, 1, 2, 3, 4, 5, 6, negative 1, negative 2, negative 3, negative 4, negative 6. There are no decimals or fractions. On this number line, we have positive integers, which is 1 to 6. And we also have negative integers, which is negative 6 to negative 1. These are our integers. When we have a set of integers, like this one, you have a set of whole numbers and their opposites. Opposite means a number that is the same distance away from 0 on the number line. For example, 1 is the opposite of negative 1, etc. Meaning 2 is the opposite of negative 2, negative 3 is the opposite of 3, 4 is the opposite of negative 4, negative 5 is the opposite of 5, 6 is the opposite of negative 6. When we have these opposites, that equals a set of integers. Now, let's talk about the gaps between these numbers on this number line. I'm going to enlarge this section of my number line below. We have 0 and we have 1. You can write fractions in between these, and if we separate it in half, we have a half and a half. This point would be 1/2 because it is 1/2 unit from 0 in the positive direction. You can also write 1/4, you can write 3/5, and you can write 9/10. These are all proper fractions. The integer 1 is 1 unit away from 0. 1 unit. Okay? So the fraction 1/2 is 1/2 unit away from 0. In the same way, you can write this distance, 1/2 unit, as 1/2 inside of these bars. These bars mean that it's 1/2 unit from 0. The measure of the distance of other fractions from 0 is defined in the same way. So 3/5 you would write as 3/5 with 2 lines across it. Let's do a couple examples. 1/4 equals 1/4, because the fraction 1/4 is 1/4 units away from 0. This is the same with 3/5 units away is equal to 3/5. And finally, 2 5/8 units away from 0 equals 21/8 because 2 and 5/8 is equal to 21/8. Therefore, this value away from 0 and this value are both equivalent to this value. And that is our example. Moving on. To the next step, we are going to find the absolute values of negative fractions and decimals. Make sure you are keeping notes of all of these steps and words. Here we go. You might imagine that a mirror is placed on the number line at the number 0. So let's draw a number line. Here we have 0, 1, 2, 3, and 4. Now let's make it a set of integers, -1, -2, -3, and -4. Here we're going to set up our mirror. Okay, imagine it's nice and shiny. That is your mirror here at 0. Now let's put a few points onto the mirror. Right here we have the point -10/3. Right here we have the point -13/5. We also put on the -1/2. We'll also put on the point 1/2, the point 13/5, and the point 10/3. As you will notice, these are both 1/2 and -1/2, 13/5 and -13/5, 10/3 and 10/3. So now, as you look in the mirror, you see the images of the positive integers. These images are negative integers. They are mirrored. In the same way, these fractions are mirrored. In a mirror, the distance of an image from the mirror and the distance of the object from the mirror are equal. When you look in the mirror very close up, you see yourself very close up. You might just see your eyes and your nose. If you back up, you see yourself from very far away. It's just like that on the number line. The 1/2 is mirrored close, whereas the 10/3 is mirrored very far. The absolute value of a negative fraction is defined as the distance of the negative fraction from 0. You find the absolute value of the negative fractions as you do the negative integers. So if we are finding the absolute value of 10/3, these bars, remember, represent absolute value. The distance it is from 0 from this mirror is 10/3. In the same way that this 10/3 is distant from 0. So if we write 10/3, it's going to be equal to 10/3. Therefore, this number does not represent a value, it represents a distance from the number line that is equal in both of these cases. You can do the same thing here for -13/5. It's going to be equal to 13/5. The same here, 13/5 is going to be equal to 13/5. -1/2, absolute value, equals 1/2. And the absolute value of 1/2 also equals 1/2. So you see the mirror. This value is a measure of the distance from the mirror. The same, the same, the same, and the values are equal. Let's try an example. Example number 1. Find the absolute values of fractions. A states, find the absolute values of negative 11 twelfths and 26 fifteenths. Let's convert 11 twelfths to the absolute value, which is inside those bars, and we'll put a negative 11 twelfths, and that is going to be equal to 11 twelfths, because negative 11 twelfths is, in fact, 11 twelfths spaces away from that mirror. Now let's try the absolute value of 26 over 15. 26 over 15 is exactly 26 over 15 away from the 0 on the number line. Now, I want you to pause. First, before you pause the video, let's do B together, and then you'll get to practice on your own. So, using a number line, show how far negative 11 twelfths and 26 15 are from 0. Which number is closer to 0? Let's draw the number line down here. We're going to draw a negative 1, a 0, a 1, and a 2. Now negative 11 twelfths is approximately almost equal to negative 1. Therefore our point is going to be here. And 26 fifteenths is somewhere between 1 and 2, closer to the side of 2. If you're not sure how to find where a fraction fits on the number line, a simple trick is to see how many times this bottom number will go into the top number. In this case, 15 will go in once. That gives us 1. And then if you subtract that from 26, you get 11. So it equals 1 and 11 fifteenths. Now I can see that it is past the 1 as a mixed fraction, and we have 11 over 15, which is not quite 2, but it's closer to 2 than to 3, because it's more than halfway through. So I put this here, and I labeled them on a number line. Now it says, which number is closer to 0? This number has an absolute value of 11 twelfths. 11 twelfths is less than 26 fifteenths. Therefore, this value is closer to 0, which makes sense. This is smaller than this. And that is example 1. I want you to pause the video and do the guided practice problems 1 and 2 on your own sheet of paper. That is all we have for today. I will see you in class tomorrow.